Hello everyone, in this video you are going to learn electromagnetic wave equation in vacuum and what is the speed of electromagnetic waves in vacuum. So let's start it. Here you can see electromagnetic waves, and since electromagnetic waves is combination of electric and magnetic field vectors, so to find electromagnetic wave equation in vacuum we need to find equation of electric field E and magnetic field B, and for finding this we will use Maxwell's equation. These are the Maxwell's 4 equations which we are going to use. But in vacuum there is absence of charge and current, hence charge density rho and current density J will be equal to 0. So Maxwell's equation in vacuum will be, these are the 4 equations of Maxwell's in vacuum. Now taking curl of both sides of Maxwell's third equation, we have third equation in this form. And LHS of this equation I can write in this form by property of vector triple cross product, and RHS I write partial with time del cross B. But from Maxwell's first equation we have del dot E equal to 0, and from Maxwell's fourth equation we have del cross B equal to mu naught epsilon naught partial differentiation of E with respect to T. Putting this in equation 1, we have minus del square E equal to minus mu naught epsilon naught double differentiation of E with respect to time, and arranging it we will have this equation in this form, and this is the wave equation for propagation of electric field E in vacuum. Similarly, taking curl of both sides of Maxwell's fourth equation we get del cross B equal to del cross mu naught epsilon naught partial of E with respect to T. And similarly I have write this equation in this form as I already showed you, because LHS of above equation is written in this way because of triple cross product property of vector, and RHS I have arranged in this way. But from Maxwell's third equation del cross E equal to minus del B by del T, and from Maxwell's second equation we have del dot B equal to 0. Hence equation third will be on putting values minus del square B equal to minus mu naught epsilon naught del square B by del square T, and arranging it we will have del square B equal to minus mu naught epsilon naught del square B upon del square T equal to 0. This equation is the wave equation for propagation of magnetic field B in vacuum. Now we are to find the speed of electromagnetic waves in vacuum. The equation for propagation of wave with speed v is del square psi minus 1 upon v square del square psi upon del t square is equal to 0. Comparing this equation to 1 and 2, we have v is equal to 1 upon under root mu naught epsilon naught. Now since mu naught is equal to 12.56 into 10 to the power minus 7 Newton per ampere square, and epsilon naught is equal to 8.86 into 10 to the power minus 12 Coulomb square per Newton per meter square. Hence v will be equal to 1 upon under root 12.56 into 10 to the power minus 7 into 8.86 into 10 to the power minus 12. And on solving this we will have v is equal to 2.99 into 10 to the power 8 meter per second square, meter per second only, and this is nearly equal to 3 into 10 to the power 8 meter per second, which is the speed of light. Thus propagation of electric and magnetic field in vacuum is in form of waves with speed equal to speed of light, which is 3 into 10 to the power 8 meter per second. Hence electromagnetic waves in vacuum travel with a speed of 3 into 10 to the power 8 meter per second.